Alright guys, in this video, we're going to be doing state diagrams and drawing state tables out of them. We'll probably get to designing this using a T flip-flop too, so we'll get to that as well. I want you to look at this state diagram, kind of study it, maybe write it down on your own because I'm going to take this away and start doing the state table. But basically what this points out is we have state 0, state 1, state 2, state 3. State 0 is 0, 0. With the input of 0, goes to 0, 1. With the input of 1, it goes back to itself. This one, likewise, input of 1 goes to 1, 0. Input of 0 jumps to there. And you can kind of see what happens here with your inputs. Each one has two arrows leaving it that kind of shows that it has an input of 0 or input of 1 option. Alright, so maybe pause the video, write this down real quick, and then I'll get going. Okay, now we will draw the state table. Let's see. The state tables are, well, with this diagram, the state table is 2-bit, so we have A and B, but we have an input, so we want to treat this as like a 3-variable truth table. So we'll start by listing the combinations. Go with the B's. And the input differences, values. Alright, now we want to do the next state. So what happens to AB when the input is 0 or 1? What state does it go to? And we'll call that A plus B plus. So 0, 0 with the input of 0 goes to 0, 1. 0, 0 input 1 goes 0, 0. 0, 1 input of 0 goes 1, 1. 0, 1 input of 1 goes 1, 0. 1, 0 input of 0 is 1, 1. And 1, 0 input of 1 goes 1, 0. And then the last two, 1, 1, input of 0, 0, 0, and 1, 1. Alright, there's our, the beginning of the state table. Shows what happens to AB with an input of 0, 1 to the next state. And that you can tell all of this using your state diagram. So kind of study that, and you can tell what's happening with the state table and the state diagram. So now let's design this using T flip-flops. Here's the excitation table for T flip-flops. It is present state, so Q, 0, 0, 1, 1, and Q plus 0, 1, 0, 1. See how it shows all possibilities. And T. So that's what the flip-flop's doing. So from 0 to 0, it's going to be 0. From 0 to 1, it's going to be 1. 1 to 0, 1. And 1 to 1, 0. Now, this is nothing like that you figure out. It's just an excitation table, so it's just what T flip-flops do. You have to just look it up or find out what this table is for, whether it be a T flip-flop, JK flip-flop, or D flip-flop. You know, so many of them. But alright, now we'll finish the state table by putting in the flip-flop values. So we have the TA and the TB. Let's see, I'll just separate these a little more organized. So TA 0 to 0, we're looking at these, what's happening here. So 0 to 0, we look at our excitation table, 0 to 0 gives us 0. And then you just keep going, 0, 0, 0, 0, 1, 1. Let's see, 0, 1, 1, 1, 1, 0, 1 to 1 gives us 0, 1, let's see here, 1 to 0, that gives us a 1, 1 to 1, 0. Alright, 0, 0, 1, 1, 0, 0. Alright, good. Now the B flip-flop. So we're going from this one to this one. So 0 to 1 gives us 1. 0 to 0 gives us 0. 1 to 1, 0. 1, 0, 1. 0, 1, 1. 0, 0, 0. 1, 0, 1. 1, 1, 0. So now we have all of the values for the T flip-flop. And now we can go ahead and start deriving our expression, our Boolean expression, using the min terms that we have for TA and TB. So let's use K-maps to solve these. So let's see, TA, we will draw our own K-map. And TB will have its own K-map. We'll draw slots for the min terms. Our three variables, A, B, X. Okay. This is TA and TB. I always like to number 0, 1, 0, 0, 0, 1, 1, 1, 1, 0. And I'll just look at this one for those, so I won't number this one. Let's see, now let's take our min terms and fill up these K-maps. So let's see, I like to 0, 1, 2, 3, 4, 5, 6, 7. Okay, so we got one at 2 and 3. I'll draw in these on this one just for reference. 2, 4, 5, 6, 7. Okay. Alright, let's fill in our ones. So 2 and 3 and 6. Now 0, 3, 4, and 6. Alright, now let's do the TA flip-flop. I think the only circles we can get here are right there and right there. So let's see, that is A naught B plus B X naught. Okay, now let's go to TB. This one we have a little bit more. So we're gonna have, let's do one here, one here, and one here. And it looks like that's gonna give us B naught X naught plus A naught bx plus ax naught. Alright, there we go. There's our two expressions for the T flip-flop. Now I think we can draw a circuit of this using the T flip-flops. I'll give you a sec to write that down because we may need this for reference. I might flash it back on the screen every now and then. But alright, let's get building. Let's see here. Alright, we're going to have the two flip-flops. I think I'll write these expressions for T on here. TA is A naught B plus BX naught. TB is B naught X naught plus A naught BX plus AX naught. Alright, so now we can start constructing. There's the T flip-flop, and here's the other one. I have a T, a B, a B naught, a and a naught. And then we'll have our other T, TA, TB. And then we'll do a clock. Alright, now let's start building the circuit. We're going to have an input over here. TA is going to be ORed. And then ANDed with these two gates. So we'll draw that. TB, we're going to have one OR. These three will all be ORed together. Connect those. And then we will have three ANDs. We'll have those all going in. Alright, now we just need to build our AND gates. Okay, first we'll have A naught, and then B, and then BX naught, oops,